Hello, physical science students. This is Mrs. Smith here. If you're having a hard time with Motion Lab, I'm going to go through a couple hints on how to make sure you're performing the correct calculations and getting the right answers. This is all using simulated data, so remember your answer should reflect your specific data. First of all, first thing you needed to do was calculate the speeds for each of the pieces of data collected. We know that speed equals distance divided by time. So to find the speeds for each of these, you had to take the distance, which was 10 meters, divided by the time, which was 6.7 seconds. And if you plugged it into your calculator, I would get 1.5 meters per second. Now remember, that's the answer for this data, not necessarily yours. Let's see 20 meters divided by 10.36 seconds. That gives you a speed of 1.93 meters per second. Now I follow the exact same strategy for the remaining ones, distance divided by time. So that I have data to work with, we'll get 4.31 meters per second, 4.72 meters per second, 0.98, and 0.91. All right, moving on. First question, which task resulted in the fastest speed? Well, the fastest speed is going to be your highest number. So for my data, that would be this one right here, 4.72 meters per second. So my answer would be running over the course of the 20 meters. That would be my fastest speed. Make sure you're using complete sentences. Number two, which task resulted in the slowest speed? So when were you traveling the slowest? Look for your lowest number. On my data, it happens to be 0.91 meters per second, which was crab walking at 20 meters. So that's what I would write about. Question number three, if you were able to keep up the same speed, how far could you run in 90 seconds? Well, what are they asking us to find? How far, that is a distance. We know distance is speed times time. And it says your speed for the full 20 meters of running. So look at your data table. The full speed of running at 20 meters was 4.72. So find that piece of information from your data table. And the time is going to be the same regardless. It told us 90 seconds. So you'd calculate it out, find your answer, and your units will be in meters. So number four, if you were able to keep up the same speed, how long would it take you to crab walk the length of a football field? So what do they want us to find? How long? We know time equals distance divided by speed. The distance they told us is 100 meters. And then we have to refer to the data table for speed. It was the speed of crab walking for the full 20 meters. So if I go back up and look, crab walking at 20 meters was 0.91 meters per second. Again, make sure you're using your data. Plug it into your calculator, and our meters will cancel, so make sure your answer is in seconds. Number five, calculate your acceleration while crab walking from 10 to 20 meters. Well, we know we need to do our formula. Acceleration is final velocity minus initial velocity divided by time. So let's look. We're crab walking from 10 to 20. Our final velocity is right here, 0.91 meters per second. At the end, that's how far we were, or how fast we were traveling. And initial, how fast were we at 10 meters? We go and look right there, 0.98 meters per second. So we're going to subtract 0.98 meters per second as our initial velocity. We're going to divide that by the time it took us to do that. So what was the time difference from 10 to 20 meters? I would have to do my 21.98 minus 10.2, and that gives me 11.78 seconds. Make sure you do the top portion first, the subtraction, then divide by your time, and your units for acceleration are meters per second squared. Number six, read our formula again. Acceleration, final velocity minus initial velocity divided by time. Calculate your acceleration while walking from 0 to 20 meters. So we're going to look at our walking data. All right, from 0 to 20 meters, we need to figure out our final velocity first. So at 20 meters, our velocity was 1.93 meters per second. We're going to subtract our initial velocity. So when we were at 0 meters, how fast were we traveling? We weren't. You're sitting there at the starting line. So 0 meters per second. Time, how long did it take us to go the 20 meters? Go back and look at your data table. To go the 20 meters, on my data, was 10.36 seconds. Again, make sure you're using your data. Again, make sure you do your subtraction up top first, then your division. When you find your answer, correct units are meters per second squared. All right, number 7, what is the difference between speed, velocity, and acceleration? Oh, for that one, you just need to look that up in your notes. Let's move on to the next calculation. All right, extension. Use the graph to answer the questions below. Number 8, 30. Well, we know we always want to show our formula. So speed equals distance divided by time. And we're talking about just swimmer 1, so we're going to focus on, I'll highlight it in red right here, swimmer 1. And we want the speed at 30 seconds, so we can fill in our time here. But we need to know the distance at 30 seconds. So at 30 seconds right here, if we travel that up and over, we can see swimmer 1 had gone 60 meters in 30 seconds. So if you divide that out, and then make sure you include your appropriate units for speed, meters per second. All right, let's look at number 9. What is swimmer 2's average speed? I'll highlight swimmer 2 in blue here. We want swimmer 2's average speed, so that would be over the entire course of the swimming. We'll still use the same formula, distance over time, but now we need to go back and look. How far did swimmer 2 go in the entire time period? Well, that far, which is what? About 50 meters. And what was the total time it took? How long did it take swimmer 2 to make it 50 meters? 50 seconds. So that should be an easy one. Make sure you include appropriate units. All right, let's look at the last question, number 10. If swimmer 2 continued swimming at a constant rate, how far would he swim by 90 seconds? How far? They want us to find a distance. We know distance is speed times time. Well, we could fill in our time really easily. They give us that right here, 90 seconds. But what about speed? What do you think? Well, we just found that right here. So you need to plug in that answer there because we know that is the speed of swimmer 2. Calculate it out. Make sure you include appropriate units. All right, that is it for the Motion Lab. I hope that helped you. If you need more assistance, please come in and see me before or after school.